Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today's lesson is going to go over section 5.7, which is something called slope-intercept form. So we're going to start by writing down slope-intercept form because that's what we're going over today. Now last time we went over something called direct variation. And direct variation is very similar to slope-intercept form, except that slope-intercept form has a variable location for its starting point. In direct variation, we started at the origin, and only at the origin. With slope-intercept form, we have a variety of places that we can appear from, or start from. So let's go ahead and do that direct variation review. For direct variation, we would start at the origin. So let's go ahead and draw our axes. For direct variation, start here. However, there are a lot of other places along the y-axis that we could possibly start. Maybe we want to start with a Maybe we wanted to start with a pretty high y value, or maybe a really low y value to start with. To do that, we need something called the slope-intercept form. So direct variation, if you'll remember, is y is equal to kx. Well, slope-intercept form is almost identical. Slope-intercept form is the one that you hear all the time, where everywhere you go, people are spouting. Every time they say a math formula, and somebody goes, y equals mx plus b. Well, guess what y equals mx plus b is? That's right. This is the Holy Grail. This is the slope-intercept form. And of course, we want to dissect it. We want to find out what every piece means. So the m portion is my slope in the form of rise over run. And the b represents our y-intercept, or where we intersect with the y-axis. So the y-intercept will always be in the format of 0, b for slope-intercept form. So if I was looking at an example, say y is equal to 2x minus 4. To find my slope-intercept, well, it's in slope-intercept form. To find my slope, I would look at the multiplier in front of the x. So my slope, you would say, but Mr. O'Neill, there's nothing underneath. Well, you can always turn it into a fraction by putting it over 1. So a slope of 2 over 1 means that we rise 2 every time we run 1. Then we have to find where on the y-axis that we are intersecting, and it looks like it's at the location of negative 4. So my y-intercept will be at the location 0, negative 4. Now we go to our graph. For our graph, we need a set of axes, an x-axis which goes horizontally, and a y-axis that goes vertically, and maybe our y-axis can actually be a somewhat straight line somehow. There we go, that's close enough. Alright, so for this one, we would have a y-intercept at negative 4, and let's graph it in purple. So negative 1, negative 2, negative 3, negative 4. Bam, there's my y-intercept. And then my slope is 2. Rise 2, run 1. So we rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And shazam, we have what should be a straight line. But for some reason today, Mr. O'Neill just can't draw straight lines. So maybe one piece at a time. How does that sound? There, that looks pretty good. So there's the graph of the line. It's pretty easy to do. You find your y-intercept, you graph your y-intercept, and then from there you use the slope to tell where you are going. So it's kind of like a GPS. The GPS, you have to know where you're starting at. Well, that would be your y-intercept. And then you need to know your directions to where to go. Well, that's what the GPS does for you. It says turn left at the next light, travel 41.2 miles, turn right at the next light, and you'll arrive at your destination on the left. Or some other ridiculous fashion. So let's go ahead and do one more example together, and then we should be good to go. Now, for at least y-intercept form, slope-intercept form. So let's look at something that's a little more complicated. Because we all love fractions and negative numbers, let's go ahead and do one with fractions and negative numbers. Let's do y is equal to negative 2/3 x and then plus 2, just to be nice. So on this one, once again, we're looking at our slope and intercept. Our slope happens to be negative 2/3. So I know that I rise negative 2 and then run 3. Or I could say that I rise 2 and then run negative 3. Both of these are equivalent, so you don't have to really worry about which ones you're using. Just remember that if you have a negative on the outside, only apply it to one of the two, either rise or run, but not both. And that way you won't get confused, because a negative over a negative is actually positive, and then you'll get the wrong kind of slope. So we need to be careful about that. The other portion, of course, is the y-intercept. The y-intercept should be really easy. It's at 0, comma, whatever that number happens to be, and that number happens to be 2 today, so it's 0, comma 2. So I know I'm going to start at 0, comma 2, and then I'm going to drop 2 and then run 3. So let's go ahead and see that in graph format. So horizontal line, vertical line, and cough. Okay, and then we start at positive 2. So 1, 2, make a dot. All right, there's my start, and my rise is negative 2, so I drop 2 and then run 3. 1, 2, 3. And then I drop 2 and run 3. And what about going the other direction? Well, I can rise 2 and run negative 3, so I'm going to rise 2 and run negative 3. 1, 2, 3. And if you'll notice, it's still on the same straight line. And there you have it, ladies and gentlemen. An example with a negative number and a fraction. Could it be any harder? Well, actually, yeah, we won't get into that till much later. It's much later now. All right, let's try this one. Let's say that we are given 3x plus 2y is equal to 8. And we are told to graph it. And we're like, oh my goodness, this is in standard form. Mr. O'Neill, I can't do standard form. It's too hard. I can't do the cover-up method. Well, it's okay. Don't panic. All we have to do is solve for y. So to solve for y, I subtract 3x from both sides. Note that there's no 3x on the right-hand side, so it's creating a new section. So I'm going to have a 2y is equal to negative 3x plus 8. Then, of course, we have to get rid of the 2, so I would multiply both sides by 1/2. And by doing so, by the way, that's the same thing as dividing by 2. I just prefer multiplying by a fraction. So the 2 and the 1/2 cancel. I'm left with just y. And then on the other side, I have 1/2 times negative 3, which would be negative 3/2, plus 1/2 times 8, which of course is 4. So there you go. Now we know how to graph it. We have a y-intercept of 0, 4, and of course we have a slope of rise negative 3, run 2. So here we go. Let's go ahead and draw our axes. Vertical axis, horizontal axis. We're starting at 0, 4, so we go 1, 2, 3, 4 up and make a dot. And then we drop 3, run 2. Drop 3, run 2. And rise 3, retreat 2. Connect the dots. Okay, So let's make sure. 1, 2, 1, 2. Ah, this last one was out of place. 1, 2, 3, 1, 2. There. That looks a bit better. I think that last one doesn't look very good either. Double check on that. It's always good to double check your work. So drop 3, 1, 2, 3, run 2. Okay. And that should create a straight line. 1, 2, 3, 1, 2, 1, 2. No. This section's wrong too. Wow, Mr. O'Neill, you are awful today. Let's try that again. Drop 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Here we are. There. And that should be a straight line. No, it looked weird. Okay. Also, lesson learned on this one. Practice, practice, practice. And double check your work. If it doesn't look right, it probably isn't. Alright. 1, 2, 3, 1, 2. Yeah, double checked. So that's it for this lesson for today. You can apply this to many things in life. Anything that deals with a constant change, depending on how many units you use. For an example, the cost of a car, or the cost of a car when you include gas mileage, or it could be something like a lemonade stand, anything that deals with an initial amount and then a change. So let's go ahead and do the before you leave work. Before you leave. So what if everything's misspelled? Oh well. So before you leave, let's do the following. 1 through 13 odd. And then we're going to also do 17, 19, 23, 25, 27, 31, 32 to 34. Now we're going to do all of them in there because it's kind of one problem unto itself. So we want to make sure that we have that one down. And I think that's going to be it for today. So go ahead, make sure that everything is good to go. Make sure that you're doing the odds. Make sure that you are in section 5.7 in Algebra 1. And it's 1 through 13 odds, 17, 19, 23, 25, 27, 31, 32 through 34. A lot of these are super easy. You should have no problems at all. Please remember that you should have your textbook at your book at your table when you start. Good luck and have fun.